Welcome to Ask and Learn.
For a 10 degrees Celsius temperature change of air, the final velocity and final elevation of air are to be determined so that the internal kinetic and potential energy changes are all equal. So the first thing we will do is calculate the internal energy change. Delta U is defined as the specific heat at constant volume Cv times a change in temperature delta T. And for air at room temperature, the constant volume specific heat is 0.718. That's 0.718 in SI units, which is kilojoules per kg degrees Celsius. And the change in temperature is 10 degrees Celsius. And so we get the change in internal energy to be 7.18 kilojoules per kg. So that's the change in specific internal energy. Now, if we equate the kinetic and potential energy changes to this internal energy change, we can calculate the final velocity and also the final elevation. So let's first equate the internal energy change to a change in kinetic energy. That is, delta U is equal to delta Ke, the specific kinetic energy change. And this is a half into V2 squared minus V1 squared. A half into the final velocity squared minus the initial velocity squared. So if we substitute our values in here, that's 7.18 kilojoule per kg. The specific internal energy is equal to the specific kinetic energy change. And this is equal to a half into V2 squared minus the initial velocity is 0. And that's meter squared per second squared. And since we have SI units, our final answer for V2 will be in SI units. And if we rearrange and solve, we get that V2 is 120 meters per second. Now we'll do the same thing and we'll equate the change in internal energy with the change in specific potential energy, delta PE. Delta PE is simply the acceleration due to gravity, g, into elevation 2 minus elevation 1 for the air. So again, we can substitute our values in here. That's 7.18 kilojoules per kg for the potential energy change, and that's equal to 9.81 meters per square second for g into z2 minus 0. Initial elevation is 0 meters. And again, we have all our values in SI units, so our calculated value for z2, if we rearrange, we get an elevation of 732 meters.